Purneshwar, am I audible?
Yes, madam. Good morning.
Wait a minute, let others also join.
Okay, madam.
లోపలికి ఉంటది ఇట్లా అయితే ఇప్పుడు నార్మల్ Yes, students, good morning, all of you. So, many of the students didn't turn on the camera. So, all of you, please turn on your cameras. Sudakshana, Adiba Kanam, Anmula, Shreya, Nashra, Sudakshana, Sipati Sudakshana, Sai Shashank. You please turn on your camera. If you turn on your camera, then I will start the class. Okay, very good. Sudakshana, turn on your camera. Hey Rohit, turn on your camera. Okay, students, welcome to Sandway Learning Services School at your fingertips. So today we are going to discuss class 9 mathematics worksheet 6 task 1. Okay, worksheet 6 task 1. Have you all taken worksheet 6? Okay, very good, children. So in worksheet 6, the chapters are included the elements of geometry and coordinate geometry. Okay, the elements of geometry and coordinate geometry. Okay, so these are the chapters which we are going to discuss in worksheet 6. The aim of the topic is understanding about the elements of geometry and coordinate geometry. Okay, and the agenda is introduction about the elements of geometry. So as it is the first day, so we are going to discuss introduction about the elements of geometry. Okay, so before entering into the topic, we all know that multiplication tables are very important in solving problems, isn't it? So if we know the tables, then we can solve the problems very easy without any difficulty. Okay, so each and every student must learn the tables. Okay, so in the part of learning tables, Purneshwar, unmute boy.
Yes, sir.
So today's table.
Sir, 17 table.
17 table. Okay, Purnesh. So read 17 table. The other students they will repeat. Students, now Purneshwar is going to recite the 17 table, and you all of you repeat it. Okay, start Purneshwar.
Multiplication table is up to 10 only, sir.
Yes.
So on screen there is only up to 10 table.
Without saying, you have to recite.
Okay, sir. 17 ones are 17. 17 twos are 34. 17 threes are 51. 17 fours are 68. 17 fives are 85. 17 sixes are 112. 17 sevens is 1.
17 6 are how much?
17 sixes are 102. 17 sevens are 119. 17 eights are 136. 17 nines are 153. 17 tens are 170.
Very good, Purneshwar. You are confusing to tell the 17 table. So today you learn perfect 17 table. Okay.
Okay, sir.
17 table, 17 times you write and you practice. Right?
Okay, sir.
Okay, very good. Students, so all of you be perfect in tables. Now coming to the topic, all of you take your worksheet 6. Worksheet 6, task 1. Okay, worksheet 6, task 1. All of you open worksheet 6, task 1. So the name of the chapter is the elements of geometry. The elements of geometry. Okay. Now introduction. First of all, we have to discuss about introduction. Nashra.
Yes, sir.
Nashra, can you please read first 2 paragraphs?
Yes, sir. You may have the large structures like bridges, dams, school buildings, hostels, hospitals, etc. The construction of these structures is a big task for the engineers. Do you know how we estimate the cost of construction? Besides wages of the labor, cost of cement and concrete. It depends upon the size and shape of the structure.
Okay. Just wait. So it is given that what is given in introduction part. You may have seen the large structures like bridges, dams, school buildings, hostels, hospitals, etc. Okay. Is the construction is a small task for engineers? No, not at all. It is absolutely, it is a big task for engineers. Why? Because should plan properly, and according to that plan, we have to construct the building. Okay. So if the plan is failed, so the building will be collapsed. Okay. So it is a very big task for engineers. And also, we estimate the cost of construction besides wages of labors, cement, concrete, everything. So we have to estimate, isn't it? Okay. Now continue, girl. Third paragraph.
The size and shape of a structure includes the foundation, plinth area, size of the wall, elevation, roof, etc. To understand the geometric principles involved in these constructions, we should know the basic elements of geometry and their applications.
Very good. Just wait. So here, in each and every construction, the geometry was included. Okay. You may take any building, bridge, a dam, a tower, anything. So if you take anything in any construction, the geometry was included. Okay. Okay. Start. Girl. Continue.
We also know that geometry is widely used in daily life activities such as paintings, handicrafts, laying on floor design, plowing, and sowing the seeds in fields. So, in other words, we can say that the life with geometry is unimaginable.
Very good. So next paragraph.
The great construction like the pyramids in Egypt, the Great Wall of China, temples, mosques, cathedral, Taj Mahal, Charminar and Altars in India, Eiffel Tower of France, etc. are some of the best examples of application of geometry.
Okay, good. So children, so every now as we have discussed before, every construction, so whatever it may be, so in every construction the geometry was included. Without taking geometry of applications, we can't construct anything. Okay. So in this chapter, we will look into the history to understand the roots of geometry and the different schools of thought that have developed the geometry and its comparison with modern geometry. Okay. So actually, what is geometry? From which language this word it was came? Okay. So first of all, let us understand. Say geometry. Okay. The word geometry, the word geometry derived from the Greek language. Okay, the word geometry is derived from Greek language. Okay. In Greek, from Greek language, the word geometry is derived. Okay. So, in Greek language, it is derived from geo. It means earth. Geo it means earth. And metria, it means measure. Okay, so the word geometry is derived from the Greek language. In Greek language, geo, it means earth, and metria, it means measure. So the measurement of earth. Okay, geometry is nothing but the measurement of earth. So first of all, so who have introduced the geometry concept? Okay, so that person we have to know. Okay, here look at the figures, children. So here a great personality, the great mathematician photo have given here. So observe carefully the photo. Whose photo it is? Sai Shashank.
కరెక్షన్ కిత్తాయో
కరెక్షన్ కాదు స్కూల్ స్టార్ట్
గదే కదా స్టార్ట్ అయ్యే కానీ
Sai Shashank.
స్కూల్ స్టార్ట్ అయ్యే లోపు కరెక్షన్ మొత్తం అయిపోవాలట
మరి మన
Here a great mathematician is given. Purneshwar.
Say Euclid.
Very good. Euclid. Okay. So Euclid, the first of all, the geometry concept brought Euclid, the great mathematician. So we call him, he is the father of geometry. Okay. He is the father of geometry. Who is the father of geometry? Euclid. Okay. Euclid is the father of geometry. So first of all, he have introduced the geometry concept in mathematics. So we call him as the father of geometry. Euclid is the father of geometry. Okay, children. Now, so what he have included, first of all, the geometry concept. Okay, and what concept he have included. So let us discuss here. See, children, here observe these figures in surface area. Okay, so if we observe these figures, see this first figure is 3D figure. It is cuboid, isn't it? The first figure is cuboid. Okay, it is 3D figure. Okay, so we all know that in cuboid there have 3 dimensions. It is a 3-dimension figure: length, breadth, height. Length, breadth, height. So from this figure, if one dimension is removed, okay, if one dimension is removed, suppose height is removed. If the height is removed from this cuboid, so what will happen? This cuboid becomes like this. Okay, it becomes a rectangle. The cuboid becomes a rectangle when we remove any one dimension. Okay, so this cuboid become as a rectangle. Okay, again from this rectangle, okay, if we remove the breadth, so this rectangle becomes a line. Okay, a line segment. This rectangle becomes a line segment. Okay, again from this line segment, okay, from this line segment, if we remove one more dimension, from this line segment, if we remove one more dimension, so this line segment becomes a point. Okay, a point. It means, so we can understand here, what we can understand here. So when we take a 3-dimension figure, cuboid, okay, so from this cuboid, so if we remove one dimension, that is height, so cuboid become rectangle. So when we remove one more dimension, that is breadth from rectangle, it becomes a line segment. And when we remove one more dimension from this line segment becomes a point. It means, so first figure is the 3D figure. First figure is the 3D figure. And when we remove one dimension from this 3D figure, it became as 2D figure. 2 dimensions, rectangle, breadth, length and breadth. Again, when we remove one more dimension from this rectangle, this 2D figure becomes 1D figure. Okay, 1D figure. Again, from this 1D figure, if we remove one more dimension, it becomes no dimension. Okay, so it becomes a point. So a point has no dimension. Okay, children, there is no dimension in points. Okay, so about a point, line, and about surface. So he have given some definitions here. Okay, what is point? What is a line? So here Euclid have given some definition. So here a point definition he have given. A point is that which has no part. Okay, a point is that which has no part. And about line, a line is breadthless length. A line is breadthless length. Already we have seen in the figure. The endpoints of a line are points. The endpoints of a line are points. Okay, so what are the endpoints in a line? So that endpoints are called points. The ends. A straight line is a line which lies evenly with the points of itself. And a surface is that which has length and breadth only. Okay, a surface which have length and breadth only. Okay, children. So like this, he have given the father of geometry, Euclid has given about point, line. So in his verse, in Euclid verse, the point, line, and a plane are called undefined terms. Okay, so in his verse, a point, line, and a plane are called undefined terms. What are the undefined terms? The undefined terms are point, line, and a plane. Point, line, and plane are called undefined terms. What we call them? They are undefined terms. There is no definition for this 3 words. Okay, according to Euclid. So according to Euclid, so these 3 points, point, line, and plane are the undefined terms. Okay, children. So remember them. Next, in the same way, again, he has given some axioms and postulates. Euclid has given some axioms and postulates. Here, some of the axioms are given below. So all of you read that axioms and understand. Okay, axioms. These are all axioms and postulates. Okay, here some postulates also given. Euclid postulates. So the first one, postulate 1. Okay, postulate 1. What is postulate 1? It is given there is a unique line that passes through the given 2 distinct points. What is given here? There is a unique line that passes through the given 2 distinct points. Given through distinct points, we can draw only one line. Okay, we can draw only one line. So let us see here already given P and Q are two distinct points. P and Q are two distinct points. So through these two distinct points, we can draw only one line. Okay, we can draw only one line. This is the postulate 1. Okay, this is the postulate 1. And one more so one more topic we have missed here. So Euclid have given definitions for 3D dimension, 2D figures, 1D figures. Okay. So according to Euclid, the undefined terms are, point, line, and plane. And he have written 13 books. Okay. He have written 13 books. That 13 books are called the elements. Okay. That 13 what we have written books. So on geometry, so that 13 books are called, okay, what we call them, they are the elements. Okay, the elements. Okay, children, this you remember. Now coming to the topic. So what is first postulate? Postulate 1. There is a unique line that passes through the given two distinct points. Okay. So here P and Q are two distinct points. Through these two distinct points, we can draw only one line. Okay. Next. Coming to second postulate. Okay. So what is given? A line segment can be extended on either side to form a line. A line segment can be extended on either side to form a line. Okay. See, according to postulate 1, PQ is a line segment. PQ is a line segment. So to form a line PQ, so we can extend this line segment on both sides. Okay. See here from Q side, the line segment has extended, and here P side also the line segment have extended. Okay. It means a line segment can extend on both sides to form a line. So this is postulate 2. Postulate 1 is through two distinct points we can draw only one line segment. Postulate 2 is a line segment can extend on both sides to form a line. Okay. And coming to postulate 3, here see circles are given here. Okay, circles are given with different radii. Okay. So what is saying about postulate 3? We can describe a circle with any center and radius. We can describe any circle. We can describe a circle with any center and radius. So here some different circles are given. So we can describe a circle with any radius from any center. Okay. So here in first circle, center P you have taken and radius you have taken 3 centimeters. We can draw a circle through this center point P with radius 3 centimeters. In second circle, you have taken center Q and radius you have taken 4 centimeters. In third circle, you have taken center R and radius have taken 4.5 centimeters. And in the next circle, you have taken the center as S and radius is 5 centimeters. So like this, we can describe a circle with any center, with any radius. Okay, this is postulate 3. Next, coming to postulate 4. All right angles are equal to one another. All right angles are equal to one another. So whatever it may be, wherever you draw the right angle. Okay. So suppose here at B will be the 90 degrees angle. Here also, if you draw like this, also here at B 90 degrees angle will come. If you draw like this, the angle if at point B it will come 90 degrees. If you draw like this, so the angle B becomes 90 degrees. It means all right angles are equal to one another. Okay, this is postulate 4. And coming to the last postulate 5. Postulate 5, that if a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, meet on that side on which are the angles less than two right angles. Here AB and CD are the two lines, and PQ is a line falling on this two lines. Okay. Here see PQ, the line PQ in figure falls on lines AB and CD such that the sum of the interior angles 192 is less than 180 degrees on the left side PQ. So the lines AB and CD will eventually intersect on the left side of the PQ. Okay. So this is postulate 5, children. So he have given 5 postulates. Okay. Now let us see. Now task 1. Exercise problems. Now I am going to ask the questions. Exercise. Answer the following. How many dimensions a solid has? Purneshwar. Purneshwar.
Yes, sir.
A solid figure contain how many dimensions?
Sir, on 2D dimensions.
3 dimensions. A solid figure contain
3 dimensions.
3 dimensions. Example, cuboid.
Cuboid.
What are they? Length.
Breadth, and height, sir.
Very good. Length, breadth, and height.
Height.
So a solid figure have 3 dimensions. So write first answer 3 dimensions. Write the first answer 3 dimensions. Next, second question. How many books are there in Euclid's Elements?
Sir, 13 books, sir.
Very good. So write the first answer 3 dimensions. And second answer, how many books are there in Euclid's Elements? 13 books. How many? 13 books. Okay. Write the number of faces of cube and cuboid.
Sir, 6 faces.
Very good. In cube and cuboid, we observe that 6 faces. Okay. So suppose if you take a dice, so if you observe that it have 6 spaces. And cuboid, a brick or duster is a best example for cuboid. If you observe that, it have 6 spaces. And in the same way, you write the remaining 2 questions also, children. Okay, this is homework. First bit is homework, and the second bit is asking true or false. So the second bit also you complete. First bit and second bit you complete. Okay. Okay, children. Now the time is up.
Sir,
So-
I have a doubt, sir.
Tell boy.
Sir, can you explain once more postulate 5, sir?
Okay. See. Okay, see here, postulate 5. AB and CD are the 2 lines. AB and CD are the 2 lines. A line PQ is falling on AB and CD. Okay, AB and CD, the line is falling. Right? So it is called a transversal. Right?
Yes, sir.
So when the line is falling PQ on AB and CD, so there 2 interior angles we have formed. Angle 1 and angle 2, both are interior angles, and they are same side of the transversal. Okay. So these 2 interior angles 1 and 2 is less than 180 degrees. Okay. So when the 2 angles are formed on the same side of this line, okay, so when we produced the lines AB and CD, they meet at a point. Okay, when we produce the lines AB and CD, they meet at a point. So this is the concept. Did you understand? Okay. Thank you, children. So all of you take username and password. Here today many only few students have joined today. So I request you all take username and password and attend the class regularly. Okay. Thank you, children. Thank you all.